So what I would like to do in this clip is go over how to set up systems of equations that we can use to model different situations. So basically, we are going to learn some strategies for solving linear systems, but ultimately we want to be able to take those systems and those strategies for solving the systems and be able to apply them so that we can actually solve problems that we would need to find solutions to. So, a couple tips before we get started. First of all, when we're reading different situations, you always look for keywords that connect operations. So, the word sum means that you're adding things. A product means that you're multiplying. The difference between two numbers means subtraction. So, those are kind of keywords that can connect operations. Um, we when I'm looking to come up with equations, I usually look at what the actual question is asking me for in a situation because the question usually has the keys to what your variables will be. And I'll come back to that idea when I'm actually walking you through a couple of these systems. And then also always make sure that you define your variables. So if you're using X or M or T or some variable to represent an unknown quantity, you always want to make sure that the reader knows what the variable that you're using represents. So make sure that you use your let statements to define the variables. So when you're looking at linear systems, there's some different types of problems that will be common that you can use to solve using linear systems. So the first type of problem is called a break-even problem. And here's an example. It says a Phoenix Health Club charges an initiation fee of $200 plus $15 a month. So it's like a monthly fee of $15 after you've paid your initiation fee. Champion Health Club charges initial initiation fee of $100 and then an additional $20 per month after that. So there's kind of the information there, and we're going to be using these numbers. But the question is asking after how many months are the costs the same? And if we look at the question contains the key to what our variables or our unknowns are going to be. We want to know how many months. So one of our unknowns is months. So I'm going to say let M represent the number of months because M is connected to the word months. The costs is the other thing that we're not sure of. We don't know what the costs are. They're changing from month to month. So that is another unknown. So I'm going to let C represent the cost. So the key to what my variables are going to be in this linear system are actually in the question. M for months and C for costs. So now what I'm going to do is I'm going to take these variables and I'm going to connect them back to our problems. So we know that the dependent variable is always equal to the rate of change times the independent variable plus the initial value. So for Phoenix Health Club, which I just put PHC, I know that the cost is going to be equal to $15 a month, so 15 times N plus the initiation fee of $200. The second one, Champion Health Club, is going to be $20 a month, so 20 times the number of months that you go there for, plus the initial fee of 100, so 20M plus 100. So we now have a linear system that we can use to figure out what the break-even cost is. So when will they be the same? When will it won't matter anymore which one you go to because the cost will be the same. We call that a break-even problem. Okay. Another type of problem that you might see is called a relative value reasoning problem. And this is just kind of when you're kind of doing some problem solving or maybe playing around with some numbers. So for this one, I have here that the sum of two numbers is 255. When the smallest is subtracted from the larger, the result is 39. Find the two numbers. So again, I look to the question or to see what I'm trying to find and what my two variables are going to be. So in this case, it says find the two numbers. We don't know what the two numbers are. We know that one is smaller than the other. So I am going to make my variables be the two numbers. I'm going to let X represent the first number, which is going to be the larger of the two. And I'm going to let Y represent the second number, which is the smaller of the two. So again, I'm looking to the question to figure out what my variables are. And now I want to use these key words that connect the operations. So it says here the sum of two numbers is 255. Well, sum means that you're adding them. So the larger number plus the smaller number is equal to 255. The second one says when the smallest is subtracted from the larger, the result is 39. Well, subtracted means that they're going to be subtracted. You're going to take your larger number and you're going to subtract your smaller number. So x minus y is equal to 39. And now we have two equations, two unknowns, and a linear system that we can now solve using the strategies that we're going to learn in this unit. Okay, and we can figure out what those two numbers are. Mixture problems can be a little bit tricky. They often involve percentages. And the main thing I need you to remember about percentages is that percentages, when we're trying to find the percent of a number, we represent them as decimals. So I'll read the question and then we'll kind of go over how we would set this one up. So it says Akeem invested $15,000. He put part of it in a term deposit that paid 4% per annum or per year, and the remainder in a treasury bill that pays 5% per annum or per year. After 1 year, the total interest is $690. How much should Hakeem invest in at each rate? So again, I'm going to the question. The question is saying how much should he invest at each rate? And I know that there's two different rates. So I'm going to let X be the amount that he invested in the term deposit at a rate of 4%. And the second one is going to be Y, which is the amount that he invested in the treasury bill at 5%. So the key to figuring out what my variables are in my question, because that's where my unknowns are found. I don't know how much he invested at each rate. That's what I'm trying to find. So that's what I'm going to make my variables. Okay, so I'm going to actually start with the second sentence second equation, because this one's easier of the two. So basically, this one just says x plus y equals 15,000. So if I take the amount that he invests in the term deposit and the amount that he invests in the treasury bill, and I add those two amounts together, straight up 15,000 is going to be my sum. So x plus y equals 15,000 is going to be one of my equations. The second equation is a little bit trickier because we have to apply our rules of proportional reasoning, okay? So basically, I want to figure out how much he would have had to invest at each rate to get a total amount of interest of $690. So my sum is going to be $690. Some of that is coming from the term deposit, which is my X, and some of that sum on interest is coming from my treasury bill. So how much comes from each? Well, 4% times the amount coming or invested in the term deposit is going to be a portion of that. So to find 4% of how much I invested in the term deposit, I'm going to take the amount I invested in the term deposit and times it by 0.04. So this will give me the amount of interest that was earned from the term deposit. Similarly, 5% interest is earned on the amount in the treasury bill. So 5% as a decimal is 0.05. I'm going to times that by the total amount that I put in the treasury, or that he put in the treasury bill, and that will give me the amount of interest that came from the treasury bill investment. So combined together, the amount of interest that came from the term deposit plus the amount of interest that comes from the treasury bill will add up to be the total amount of interest, which is $690. So that gives us our second equation. And now we have a system of equations, two unknowns that I will teach you how to solve using some various strategies. Okay, so this is called a mixture problem because basically we start off by taking two amounts, adding them together to get a total, but then we take pieces of an amount, of 4%, the 5% of those amounts. In this case, it happens to be interest. And we piece those together to figure out how much overall interest was earned. The last one is probably the trickiest one. They're called rate problems, and they kind of use some formulas that you might have learned in one of your science classes, connecting distance, speed, and time. So you may have seen this little rate triangle before. the way that I always remember it is I always connect it kind of to the formulas to driving down the 401. So if I'm driving down the 401 and I'm driving 100 kilometers an hour for 5 hours, how far did I go? Well, if I was going 100 kilometers an hour for 5 hours, I would take 5 times 100 and I would get my distance, which would be 500. So that's how I always remember this one here. So the distance that something goes is equal to its speed times its time. And what I can do is I can either rearrange this equation or I can use my rate triangle to come up with some other equations. So for example, if I want to get the s by itself here, I could divide both sides by t, and I would get the equation s equals d over t. If I look at my rate triangle, I can cover up the s, and I can see that s then is equal to d on top and t on the bottom. Along the same lines, if I want to isolate for t, I can divide both sides by s. So I would get t is equal to d over s. So if I cover up my t here, I can see that it's equal to d over s. So here are 3 equations that connect the distance, the speed, and the time. And we're going to use these 3 equations to help us solve or set up the equations for the next rate problem. So for this one here, we have a situation where Erica drove 50 kilometers per hour from London to Coburg. From Coburg to Kingston, she drove 80 kilometers per hour. And the whole trip was 550 kilometers and took a total of 8 hours to drive. And our unknowns, what we don't know is we don't know the distance we're trying to find the distance from Coburg to Kingston. So I let C be the distance from Coburg to Kingston. Well, there's something else that we don't know as well, and that would be the distance between London and Coburg. So I let L be the distance from London to Coburg. So again, this last sentence where the question is drove where I was going to be looking for when I wanted to come up with my variables. Okay. So in a rate problem, we're going to connect these variables here and the numbers in my problem through, and I always like to make a little chart here, and I can use my chart now to help me come up with some equations. So for example, I'm going to be looking at the distance between London and Coburg, and I'm also going to be looking at the distance between Coburg and Kingston. And for each one of those distances, I want to look at the time, the speed, and the distance. Well, when I defined my variables, I let L be the distance between Coburg and London. So I'm going to put that L there. And I let C be the distance between Kingston and Coburg. So there's my C. From the question, I know that between London and Coburg, Erica was going 50 kilometers per hour. And between Coburg and Kingston, she was going 80 kilometers per hour. So I can fill in my speed. And in terms of time, well, I know that time is equal to distance divided by speed. So the time from London to Coburg is going to be equal to the distance, which is L, divided by the speed, which is 50. So L over 50. The time between Coburg and Kingston, again, is equal to distance over speed. So the distance from Coburg to Kingston is C, and the speed is 80. So there's my C over 80. And I know from the question that the total time from London to Kingston is going to be 8 hours. So if I take my time between London and Coburg and my time between London and Kingston, and I add those 2 times together, I'm going to get a total of 8. So there's one of my equations. L over 50 plus C over 80 equals 8. Okay. There's also another equation that occurs here. I know that the distance between London and Coburg and the distance between Coburg and Kingston in total is 550. So L plus C must equal 550. And now I have a situation where I have 2 equations and 2 unknowns, and thus have created a linear system. So I find for rate problems, I always define the equations that I'm using right off the bat. And then I split it up into a little chart, and the chart helps me to be able to see naturally what the equations are actually going to be based on the variables that I defined from the question that was being asked. Okay, so in this course, these are the 4 types of problems that we will be looking at. Today, we're going to just practice setting up these systems of equations. And then once we learn strategies for actually solving these systems of equations, we will come back and we will figure out what the actual solutions to these systems are.